Hello, it's me, your teacher. I'm going to just go through this slideshow via video in the hopes that that means that you'll be able to actually hear what I am saying. If we really hate this, then I'll stop doing it, but I just want to see how it goes today. So, the mole, I introduced this a little tiny bit in class yesterday, but I'd like to go through it a bit more slowly today. So we had a bit of a think about the fact that the mole is kind of like a chemist's dozen. So in each of those words, they each represent a fixed number. So when we think of a dozen, we always think 12. We don't think 6, we don't think 32, we always think the number 12. So the dozen always means 12. Same for a grand. When we say that we have a grand, we think that we've got $1,000. We don't think $200 or 400 cats. We think $1,000. So it's a fixed amount and sometimes also a fixed thing. So just like a dozen, where the word dozen represents a fixed amount, so 12 things, a mole also represents a fixed amount of atoms or molecules. So a dozen atoms would be 12 atoms, but 1 mole of atoms is equal to 6.022 times 10 to the power of 23 atoms, or this massive long number. So chemists are lazy. That's pretty much the tagline for this course so far. This number is too big. I don't want to have to say that all the time. So instead of bothering to say it, we simply say that when we have 6.022 times 10 to the power of 23 atoms, we have 1 mole of atoms. This number is also known as Avogadro's constant. Amadeo Avogadro didn't discover this number, but it was named after him to thank him for his work towards the discovery of the number. He started off his life as a lawyer and then got really interested in maths and physics and then became Italy's first physics professor. So that's pretty cool. And he came up with the law that then informed the discovery of the mole, which is that if you have 2 gases at the same temperature and pressure, they will occupy the same volume only if they contain the same number of molecules, which is known as Avogadro's law. So to put things in context, a mole of donuts would cover the Earth in a donut layer 8 kilometers deep, and a mole of 1-cent coins, if divided evenly between the 7.8 billion humans on Earth, would leave everybody with $772 billion each. So it's a pretty big number, which is why we don't bother to say it, and instead we just say we have a mole. So if we had a mole of elephants and a mole of carbon, they would both contain the same number of individual parts, but obviously the elephants would take up more space and have more mass than the carbon, but we would have exactly the same number of individuals in each of those samples. This doesn't change for different types of atom or molecule, so 1 mole of copper sulfate contains exactly the same number of particles as 1 mole of iron. Even though it technically contains more atoms, it has the same number of particles because that copper sulfate is bonded together to make 1 unit. So each of those copper sulfate units would add up to make 6.022 times 10 to the power of 23 units, or a mole of copper sulfate, and each of those single iron atoms would add up to the same number. They will both have different masses and will take up different amounts of space, but both contain 6.022 times 10 to the power of 23 particles. So a mole is a mole is a mole.